Hi, welcome to the new video. And in this one, we are going to discuss the goodness of fit of the model and how to measure it using r² and adjusted r². So please consider the following regression line. So for this particular value of x, we have three corresponding values of y. So this is the actual value of y based on the data. This is the predicted value of y based on our regression model, and this is the mean value of y. So if you calculate the distance between the actual value of y and the mean value of y, put it to square, and then sum up all those differences for all the observations, then you will get total sum of squares, or TSS. If you calculate the difference between the actual value of y and the predicted value of y, put it to the power of 2 and calculate the sum of those squares for all the observations, you will get residual sum of squares. And finally, r² is equal to 1 minus the ratio of RSS to TSS. You typically interpret it as the proportion of variation in dependent variable, which can be explained by the model. So it's always somewhere here in your estimation output. So in this case, our model explains approximately 21% of the total dependent variable variation. Of course, more is better, but it's not always that high. Everything depends on the model and on the data. So when it comes to regression models based on some fundamental economic theory, then r² is typically quite high. However, when you analyze the changes in the prices of stock, for instance, then even 0.10 might be a pretty decent result. So you have to compare your r² with what was reported in earlier studies. However, there is a trick related to r², and the trick is that if you add more variables, then your model will be better in terms of its ability to explain the variation in the dependent variable. However, the true explanatory power of the model is kind of undermined. So you have to determine the key determinants of the dependent variable, not all the possible determinants. So if you use adjusted r², you can easily fix this bias. It is calculated according to the following formula: 1 minus k over n times r², where k is the number of parameters or variables, and n stands for the number of observations. So for instance, this is the model with two independent variables, and you can already see that adjusted r² is lower than r², because on one hand you added more variables, on the other hand you have to deal with the fact that it's a kind of a cheap trick to improve the goodness of fit of your model by adding more and more variables. So that's why typically adjusted r² is lower than r². Okay, so that was it when it comes to the goodness of fit. Thank you so much and see you in the next video.